Here in this video, we are solving two questions that appeared in NEET 2023 in system of particles and rotatory motion. The first question is this. The angular acceleration of a body moving along the circumference of a circle is in what direction? So first we need to understand when a body is moving in a circular motion, what happens. So if you look at the body, there is a little disturbance is there on the screen. So if you look at the body, just give me a second. Come on. Yeah, when a body is moving in a circular path with a velocity v, at any point its velocity is tangential to the path. It's having acceleration towards the center called radial acceleration or centripetal acceleration. A radial for the body towards the center is mv square by r or mr omega square. So that's the force. So v square by r, as you are writing only acceleration. So it could be written like acceleration is v square by r or r omega square. Force will be mv square by r and mr omega square. Simultaneously, if the velocity of the body is changing with respect to as the velocity is changing with respect to direction, it will have acceleration along this direction also called tangential acceleration. Here tangential could be written like A equal to r alpha, where r is the radius of the circle, alpha is called angular acceleration, that is d omega by dt. So a body is now parallelly having two kinds of accelerations, tangential acceleration and radial acceleration. The resultant of these two accelerations is perpendicular to both of them. That's the resultant acceleration. So resultant acceleration of the body is root of ar square plus at square. A radial is r omega whole square, that is r square omega 4. At equal to r alpha, that is r square alpha square. This is how we can calculate resultant acceleration. A radial is towards the center, A tangential is along the tangential path of it, but the resultant acceleration is along the axis of rotation, right? So the answer as nothing is mentioned, we assume here that the body is non-uniform acceleration having both these accelerations, and hence we can say its acceleration, resultant acceleration is along the axis of rotation, because the resultant of these two will be along the axis of rotation. That's how we solve that first question. Let's have a look at the second question. What is that? The ratio of radius of gyration of a solid sphere to that of a hollow sphere is how much? It's a very simple, but we are here taking the formula. The derivation we are not making here, it has to be done with integration. We have done it, we can see it later. So it's a solid sphere. Solid means it's not empty, it's inside, filled with the content like a cricket ball, whose if its mass is m, its radius is r. Moment of inertia of a solid sphere about its natural axis is 2 by 5 mr square. That can be equated to mk square to get the radius of gyration. From here, radius of gyration is root of 2 by 5 times of r, right? And if you take a hollow sphere, this is a solid sphere. If you take a hollow sphere, inside it is empty like a plastic ball. The moment of inertia of the hollow sphere naturally is 2 by 3 mr square, which can be equated to mk square. So k equal to root 2 by 3 times of r. Then radius of gyration of a solid sphere to the radius of gyration of a hollow sphere ratio will be root of 2 by 5 r by root of 2 by 3 times of r. So all these things will mean 2 and 2 will cancel, that is what happens. So you cancel them, 2 by 5 and 3 by 2, r and r also cancel. So the ratio will be root 3 is to root 5. So the answer has to be root 3 is to root 5. I am not sure whether the options are having that root 3s and root 5s in a real original paper that was given in the examination. So, but it has to be having that root 3 and root 5, and then only it will be correct, right? That's it, and thank you for watching.